Lesson 19. Understand conditions for drawing triangles. Lesson objectives. Content objectives. Students will be able to construct triangles given angle measures, side lengths, or congruence. Students will be able to determine whether or not it is possible to draw a triangle with given characteristics. If so, draw the triangle. If not, explain why not. Students will be able to determine whether a triangle is unique. If you can draw more than one variety of that triangle, or if no such triangle exists. Students will be able to draw a quadrilateral when given a description of side lengths and angle measures. Language objectives. I can demonstrate understanding of the conditions for drawing triangles by summarizing the conditions of side length and angle measures. I can discuss how to form quadrilaterals with given side lengths using the terms adjacent, non-adjacent, and parallelogram. I can explain the greatest and least possible values of x using conditional statements. Prerequisite skills. Understand the concept of a triangle, sides, and angles. Draw line segments and/or angles of given measures using appropriate tools. Lesson vocabulary. There is no new vocabulary, but we should review the following key terms. Quadrilateral, a four-sided polygon. Condition, characteristics or circumstances needed for something to occur. Conjecture, to form an opinion with limited information. And experiment, to try a new way of doing something. Learning progression. In grade 6, students drew polygons in the coordinate plane and used the figure's coordinates to find the lengths of sides. In this lesson, students explore drawing triangles given different sets of conditions. Side lengths, angle measures. They use straws, rulers, protractors, and patio tracing paper to construct triangles and quadrilaterals from given side lengths and or angle measures. They conclude that some conditions will not let them draw a triangle, other conditions result in a unique triangle, and still other conditions result in many different triangles. Based on this work, students generalize concepts that help them form quadrilaterals from given sets of conditions. In grade 8, students will use these skills as a foundation for determining congruence and similarity in two-dimensional figures. Let's understand conditions for drawing triangles. Think it through. What side lengths form a triangle? You have worked with triangles for several years. You know they have 3 sides and 3 angles, and they seem pretty simple. But can a triangle have any side lengths? Can a triangle have any angle measures? Try an experiment. Pick random numbers or roll a number cube and try drawing a triangle with those side lengths. You will find some combinations of side lengths form a triangle. In this lesson, you will learn which combinations do or don't work as sides of a triangle. Can these 3 sides lengths form a triangle? These ones. 1, 2, 3. What you need to do is I would take maybe a string and cut it that measures the screen on your computer and see if they can form a triangle. You can also take a piece of paper and measure these 3 line segments, cut those, and see if you can form a triangle. That's what I would do. So here I put in lines just to see if these connect, and when you try those, you can see that they will most likely not connect. Watch. If I put this here and I just boom, I put this here and boom, these will not connect. So these will not make or form a triangle. Think, if you know its side lengths, you know everything about a triangle. Right now, we want you to cut a straw or a string, you can even use papers, into lengths 3 centimeters, 4 centimeters, and 5 centimeters. Use the 3 pieces to form a triangle, and carefully trace the triangle on paper. Then rearrange the sides to form another triangle and trace that one too. Okay, obviously in this situation, we have to wait in the classroom to compare the 2 triangles and compare yours to other students' triangles. Compare your triangles to the one shown here. Be sure to measure the angles with a protractor and compare the angles too. If you work carefully, you'll be able to understand why we can say that if you know the side lengths, you know everything about a triangle. Any 2 triangles with the same side lengths will always have the same angle measures too. Think, if you know its angle measures, you don't know everything about a triangle. Use a protractor to draw a triangle with one 90-degree angle, one 30-degree angle, and one 60-degree angle. Try to draw another triangle with the exact same angle measures, but with at least one side a different length. If you can do that, try another one. When you have drawn several triangles with angles measuring 30 degrees, 60 degrees, and 90 degrees, compare them. Compare your triangles to the 2 shown here and to the other students' triangles. And then again, that's when we get into the classroom. Let's reflect. In what way does knowing the measures of the 3 sides of a triangle tell you more than just knowing the measures of the 3 angles? Question 1. In what way does knowing the measures of the 3 sides of a triangle tell you more than just knowing the measures of the 3 angles? Think about that. If you did the work carefully, you would have a better understanding of this. Pause this video, answer your question. When you unpause it, you will get your answer. Here's one possible answer. When I was given the side lengths, all the triangles were exactly the same. When I was given the angles, I could draw different sides triangles that have the same angles. Let me give you an example here. Okay. If I have, let's say, a triangle like this, okay? And this measures at 90 degrees, let's say. This measures, let's say, I'm just making this up right now, 40 degrees. And this measures at 50 degrees, right? 50 plus 40, sorry for mess up, 50 plus 40 is 90, plus 90 is 180. Remember, the sum of all interior angles of any triangle will always be 180 degrees. So write 50, 40, and 90. Okay. Watch what I do now. If I take this triangle and make it the length's a little bit different, guess what? 40, 50, 90. This is still the same. Okay. I know it's not drawn to scale, but I'm trying here. Okay. So again, I can make this, right? Think about that. If it's the side lengths are the same, trust me, all the triangles will be exactly the same if you're given the side length.